Tom's Cards and Gifts and Coffee, or Coffee, Cards and Gifts. Little Creek Farm Store. Arthritis version handle almost. Just needs to be a little thicker, but it's big enough. Piston Talk. I said I was going to get downstairs. I have some work to do down there too. And before you think I'm nuts, I can't remember if this came off a hydraulic cylinder. I think it did. What did I save it for? Just because. I'm pretty sure the only other place it could have come from would be a tie bar on a hammer, and I don't think I've worked on a demolition hammer this large. So that would be one from a hydraulic cylinder. But I was hoping to put a little spark in my talks. Oops, this won't come off. And believe it or not, this is a Champion spark plug. Brand spanking new. I don't know how or where I got it from. Registered U.S. Patent Office. Made in USA. It's a 9COM, C-O-M. Charlie Oscar Mary. Or Charlie Ocean Mary. Or, you know what I mean. But anyway, I love to have these. I had one at one time and I lost it. Jim McFadden used to give me some of these things for the fun of it. McFadden and Sons up there in Sharon Springs. And there was a company called Auburn, and he bought a whole stack of Auburn spark plugs. And he kept them around for some of the locals and people that he cared about. And well, whether he cared about me or not is probably irrelevant. I was the closest neighbor that worked with him quite often. And I went up and bought a bunch of Auburns from him, and he was correct. They've been out of business for a while. They were the best spark plug on the planet, bar none. They're phenomenal. Absolutely phenomenal. But you could never get any more. However, also, going back a few years, some of you old guys might recognize the original battery tester. You see, why does it have points, and why does it have, well, essentially, this tells how many volts there is. But the idea of the volts is this is your load tester between the cells. Now, the old batteries when I was a kid, and they were just getting away from it then in the 60s, was they put, the battery cells were individually manufactured for different size batteries. You could have a 6 and a 12 all in one, and believe it or not, on some of the larger frames, you could have 6, 12, 24, whatever, and the cells came, and you put them in a package, and then sealed them together with kind of a slash rubber slash tar sealant. True story. And at the top were tie bars. And most of them in the older days were exposed. Nobody cared. You're supposed to take care of your battery, keep it sealed. With forklifts, what we used to do, and I was taught this by a fella at William Tom Forklifts back in the early 80s, that we would blow air across the top of the battery for a while. Just gently blow some air, fan or whatever else. Take the caps off even. Loosen them up at the very least, but blow air across it. Be sure there was no bubbling, no charging, no hydrogen or anything else around. And literally, we would take an open torch, and where that rubber was, it'd start to crack, and we'd essentially heat it and weld it back together. The tie bars between the battery straps, so what this was for, is to go across the tie bars from one cell to the other. Now, the tie bar went from one cell to the other, but you were looking from one cell to the other, even across the cell itself, as close as you could get to the tie bars, and it would give you a voltage reading with the load. It's pretty cool. Price, $10. I don't even know if it works, don't care. It's a beautiful thing. Got to hang that in the wall out in the shop. I got to make a wall in the shop. That's one thing. Next on the list, we're going to do a piston talk. Well, let me put my glasses back on, because here's my piston. I got through with my show and tell. Okay, you see that wear mark here? You see all the scuzz on the side. This thing rarely ever had its oil change. And it got run very, very rarely. I know the machine. I own it now, but I drove it. And this is the original guts. And I drove it back in 1969, maybe 68, 69. It's a 20 horsepower VAC case. And crap would build up on the side because there was no, well, we just didn't take care of the tractor at the time. Another one of the things that this is in your forensic studies. Immediately, you know for a fact this piston's been sitting around for a while. I'll wipe it off with my shirt that's going to go in the hamper here shortly. But you can see it doesn't come off. That's an oil film that's on there. And now this is indicative, probably from years back, of non-detergent oil. What else is it indicative of? Over here and here, since it's relatively even, but not perfectly even, the rod and bearings were loose. Also, that there was a lot of dirt down here around the skirt. So there was very dirty oil for a very long time. Also here, that was scuffing. The oil did not have a very good film integrity. So, and a little pitting from water and other stuff sitting there. But you can see the lines up and down, and you see the little teeny black marks. That's even dirt embedded in the skirt. Similar on this side. Now one side, this side is most likely the actual thrust face. Meaning that when the piston fired and it's rotating over, that face was on the right side of the tractor, and as it pushed the crankshaft down, it would the rod would be at an angle, push it to the side. You can also see at the bottom of the skirt similar. What else can we see by reading this? Well, you can look at the top rings. See there's two different, a nice shine here and a dull finish there. Now this one was probably chromed and steel, and this one most likely cast iron. You can also see they're square edged. This one actually has, the second ring does have some junk in it. What else do you notice? Well, one of the biggest things for me is look at the oil ring. It's flat. The oil ring also has scraper rings on either side of it. And they have no expansion in them. They're just in there's spacers for the oil ring. But when the oil ring is worn that flat, it's burning oil, obviously. What else can we learn? Not a lot. The backside just proves that it got warm a few times, but never overheated necessarily. But there's a film from the paraffin and other stuff in there that was in the engine. Oh, she's going to hate me for this one. But it's my clothes, so she won't. Now on top, you know it's running rich. You also notice that I was talking before about a line around here. When you start to see that clean all the way around, what do you also notice? Well, that's air, dirty air getting in there, plus deposits on top that are relatively fluffy. Now you're going to say that's carbon. Well, yes, but carbon needs something other than gas usually, and that's because of the style of deposits. You know, there was dirt that got in there. Now, there's a third ring that's missing. I can't, who was it? Was it Don Livingston, or was it, I can't remember who it was out there in California. Has Case and John Deere Specialties. Rusty Akers. And he sent me a set of rings that were in nice shape out of another case. And some bearings that were in very good condition. I'd be able to make this tractor run if I can get the block fixed. The block is cracked and I made some repair, but the problem with the repair is now the counter bore is going to be off just a fraction. And the way it's going parts from my boring bar, I'm going to have to clean it up by hand. Well, how do you do that? I've got the deck flat. I took a piece of steel, put it on a platen sander, and got it flat. Checked it with a straight edge. For you purists out there with your little buzz wheel machining, look, the high-speed CBN PCD cutters, they're the cat's meow, man. I'm telling you what. They're the bull's stuff. They are, yeah, okay, if they're set up right. I had an RP 1200 Peterson years ago, and we had a major problem in the area. And one of them was some of the guys had broach machine over the hill, and then there was another one that did have the high speed, and another one had a broach, and they all set a heavy lead on it so the tail didn't touch. That way they could cut heavier. Well, if you didn't cut heavy, you're doing your light cut, you have a terrible 2000s lead, and it made a low center. One guy brought his heads to me with my platen sander. He checked before and after each time, and found out that I made a flat aluminum surface where the other guys had a 1 to 2000s dip in every one of them. Broach, CBN, well, PCD in this case, high speed. So don't tell me you don't like your platen sanders. And don't tell me that didn't make that steel plate flat. So what the straight edge is for. If you can't get 1/1000ths under it, you're golden. Why? Well, because the surface imperfections, your RA, your roughness average, now they got peaks and valleys and roughness average and all this other stuff, is important. Well, I have more manual control, and you guys in some cases with your what do you call it, machines there, automated, they can control the surface themselves. I don't have that, but I can get it down to a nice, beautiful. To get it with a PCD cutter, I was told to use CBN until, I don't know why, but when I went to the PCD, there were certain cast iron heads that worked okay with it, and the aluminum, if you were careful with it, made a nice light 1 or 2/1000s cut with WD-40, almost glass. Well, I can't quite get that with a platen sander, but I can get it so it looks sweet. Well, what's the idea? Well, the idea there is aluminum walks. Doesn't matter what you do, even with dowels, aluminum expands and contracts. That's why you find most aluminum heads don't have dowels, because the block is cast iron. It's faster heat, it's faster contraction and expansion rate. Okay. Now, even in the cast iron blocks, the only reason the dowels work is your combustion chamber is near the deck surface, so the head, the deck, and everything expands and contracts similarly, but a lot less than aluminum. So putting dowels in iron and steel, it's beautiful. Anyway, to get back to the piston here, and that's why I'm having trouble with that, is I'm going to have to take my hand and work it. Well, it's like everything else. You can do it. Just take your time. Use your head, and when I'm done, yes, I may have to actually shim that sleeve. So, and my boring bar, even if I can't get all the parts for it, will still be very useful for cutting counterbores. So that's one of the reasons I got it. Counterbore cutters were size specific and $3,000, $4,000, $5,000 a piece. I got $800. So, that's one of the reasons it says multiple side rings for the oil ring. But anyway, 3 compression rings, which is probably unnecessary in this tractor. But if you have space for it, you put it in there and run it. Why do they run fewer rings? Some 2-stroke engines run a single ring piston. They get a little more blow by, but they run like a mad bandit, less friction. 2 piston rings is for higher compression, and then it'll slow a 2-stroke down to some extent. It won't be as snappy, but they'll have more torque. Why? 031 steel, nickel sill cylinder, and a single ring piston. 032 steel, the last run of the 03 series, 2-ring piston and a chrome cylinder. Let me tell you, yeah, it was a little slower. Torque, life, but almost doubled. So that's why quite often the top rings are steel and chrome. And then you have 2 cast iron. Now on gas engines, I don't know if I can take it off because these are pretty substantial. You can almost see it though without me taking it off. Yes, I know there's 1,000 things I should have done. I just don't care. Hey, there we go. Beautiful. Now, almost all rings are like this one. And I don't believe the second has. No, it doesn't. These are the older ones. All right. Now, most especially top rings, you'll see here, it is labeled top. It really is. TOP. Why is that important? Well, In some cases, you'll see the profile of the ring. In some cases, they'll have a taper on the inside of the ring. I mean a total taper from top to bottom. And it'll be more open at the top for compression pressure to get in there. In other cases, it'll have an actual, well, they'll chamfer the upper corner here all the way around, and then underneath it will be straight. If you put it in upside down, not good. The other one is, on some of these, they'll have a slight taper to the face up to hold compression in. The next ring, your second ring, as is this one, also is marked top. Well, you might not be able to see it. Let me see if I can modify that. Yeah, there it is. Marked top. And the reason for that is the face of this ring, instead of being this way as the top ring may or may not be, perfectly straight at top or a little wider at the top, this one be at the bottom. Well, this one usually is straight, and the third one will be wider at the bottom to act like an oil scraper ring to help the oil control ring. Sounds crazy, but that's usually why there's three. 2 compression, 1 scraper, 1 oil scraper. A lot of them are like that. Your John Deere's will be set up similar to this one and have another oil ring down here at the skirt. That's why you can't sleeve the cylinders very well unless you go all the way through, glue them and pin them in place. But you can do that. So what's another one? Some of these are actually designed internally to flex. Instead of having a tapered outer edge, they'll actually be tapered on the inside edge and designed to flex. Now also a keystone ring. You see how we have a square end here. Keystone ring, the inside surface here at the tip will be narrower than it will on the outside. Well, what's that for? Same idea. When compression hits it, it's a little bit loose in the groove, but it's in a special iron inserted or steel inserted groove. And this is a steel ring with a chrome face, or chrome moly steel, depending on how they build them. But the taper allows it, when the compression hits it, it hits the taper and causes expansion both from the pressure and the pressure down. So it runs across that tapered edge and makes a little better seal. Diesels, that's almost strictly a diesel engine. Now this one, believe it or not, one of the reasons it's shiny is, take a look. Notice on the outer edge is a little different color. There's still a little bit of chrome face left on that one, strangely enough. So this ring's probably why the different color. In here will still be steel or cast iron, usually steel with chrome. And the second ring is almost always a moly. No, it's not. This one isn't moly inserted, but it's a cast iron ring. What's a moly insert? In here where it's chromed, there actually be about a 5/1000 edge out here. This is on cast iron, so there'd be a 5/1000 iron edge out here, 5/1000 on the other side. In between, all the way around will be a perfect machine groove, and they will impregnate molybdenum disulfide type of moly metal in there, and it acts like a lubricant. A lot of automotive cars have that because of one major reason. They're not expecting them to take the load. A piston like this is designed for 75 to 100% load all the time. Every time you let the clutch up and drive someplace, they expect that 75% of the time it's going to be under a load on the high end of it. So if it's rated 20 horsepower, they're expected this thing to work almost to the 20 horsepower range 75% of the time. Automotives, 25. Quarter of the time, they expect it to be under some type of load. That's it. So they build the engines accordingly. It's like Chevy used to do it, and then gave it up in the 70s, unfortunately, and didn't change it until late 80s or 90s. But they used to build their engines like Ford. You had a car engine and a truck engine. You may have a 302 in your car. It doesn't do much for the 302 in your truck. Everything is different. The metal in the block's different. Rods, pistons, heads, everything will be different enough that, oh yeah, maybe it'll bolt on, but it ain't right. It's a different 302. 2.3 Ford 4-cylinders. Oh my goodness, the difference in the trucks compared to the cars. Man, they'd have blow-by in those little engines working their guts out 100% of the time. And there'd be little service trucks full of half a ton of tools all the time, rolling up and down the street with their little 4 or 5-speed transmission. Blow-by on the ground, but engine's still running 200,000 miles. Oh yeah, totally different than the car. That 100,000, you better be looking to overhaul it. The truck, it probably should have been overhauled, but it's still going. I saw a few, more than a few. Anyway, that's the idea there. Plus the truck engine, I'm sure some of the truck engines did run a chrome top ring. Well, to run a chrome top ring, your black has to be tougher. Why do they have differences? The differences is if there's two different metals, one of them acts as a sacrificial metal as they rub at each other. That's why a lot of steel shafts have brass bushings that they ride in. The bushing is what gives. But because the bushing is softer, the harder metal can cause the bushing to actually shine itself. And that's another reason for it. It's one of the reasons aluminum works so well in cast iron sleeves, steel sleeves. It's the sacrificial metal, but at the same time, the two can slide across each other, and the differences in temperature, wear, and everything else, the friction is much lower. So a few contacts here and there doesn't cause any problem. So when we go back to it, something else to notice too is here's the top side of the ring. You see how shiny it is? It's made a lot of cycles. And look at the bottom edge of it. Completely clean. And the top edge has some varnish and garbage on it. And that's something else to look at in your ring ridges and your piston grooves. See how much carbon's in there. Makes a big difference in how they work later. This piston's going to end up being reused. I don't have a choice because of money. But there we can see it. You can see the dirt all the way around from here from dirty oil, which also is a bad breather, or you're in dusty environment. It's going to happen. And the only way to prevent it is to change your oil often. This is a bypass oil filter, which is marginally better than just running straight oil and changing it a lot. Like every 50 to 100 hours, about 100 hours. If you change your oil in these old tractors with bypass filters at 100 hours, you're going to keep it clean. That is your filter, because it'll carry a lot of stuff, bring it into the pan, get it all fluid. Like they say, warm the engine up before you drain it. That's mostly in the older engines. Because of that, you'll have it all moving around and flushing around in there. Then you go to drain it. There's a lot of suspended garbage. It comes out with the oil. And that's your filtering, even more so than the filter on a bypass system. So we've seen dirt, crap embedded in there. We've seen the varnish and other on here. That can come from heat or just plain age, or age combined with heat. Your carbon on top, it was running far too rich, but also had a lot of dirt go through it. The other thing that'll do this too is if you have a rich mixture or a proper mixture, you set your tractor up to go out and plow an acre garden or half an acre garden, a fair sized plot, your little case or your little 8N Ford or whatever. And you've got it set up and adjusted perfectly for that. And then you get done and you go out and mow hay or spread manure. It's under a nice high heat, high compression, high load. How do I say high compression? So, well, it's already 6-to-1. It's not high. No, not there. The compression ratio isn't any higher. The compression pressure is. Because your throttle opens up and you're getting more air-fuel mixture in there. That means there's more to compress in that 6-to-1 area. So your pressure goes up. You're all set for plowing. Running beautiful. Why? Because it's hot. Nice and warm. The engine loves it. It's right in its element. Right there in a borderline of maybe too much, but you're in its element. It loves to work. Then you go out and spread manure. Engine's still happy, but your piston never warms up. So it ends up being a cool spot, and you will get the oily deposits from stuff getting by here, but you'll also get fluffy and deposits from the fuel that's not completely burned. This is just not hot. But then it's the same mixture under a light load as it is under a heavy load. You say, well, it's a fireball in there. Yeah, it's a fireball, but it's a smaller fireball. There's not so much air and fuel in there to completely burn. The other part you know that there's dirt going around in there and coming from the bottom is it's nice, shiny, clean edge all the way around. Nice, shiny, clean edge all the way around. Dirt coming in. So those are some of the ways that you can know that there is dirt. Now this one, if you were able to see it any closer, you can actually see vertical lines in the cast iron ring. So those are a lot of things that you can learn. There's varnish in the oil. A lot of stuff that can tell you that maybe, like in this case, everything is generally okay. The tractor was running fine. Everything was the way it should be. Now mind you, if I go to put this on here and I'm not careful, I can cut my fingers on those sharp corners. But that's what you need to do with your forensics when you're tearing it down. They'll call it failure analysis anyway, but in this case it's forensics because the engine was running and generally running pretty good. Just the tractor got to the point in its life where on the farm that it was on, it didn't have a purpose. So it started to get parted out. And then I got into it, and my fellow out there at Rusty Acres sent me a few pieces. He charged me a few bucks, but that was nice because he's hoping to see this antique run before I die, or before he dies. I've had the tractor for darn near 20 years now. And I've been trying a little bit here, a little bit there, and it's like you get discouraged. And I've been working for all these years. Now I have the chance to do some work on it, and somebody's going to do some work on our house, and this stuff is kind of in the way down there. I'd love to take the workbench I have down there and put it out in the workshop. There's a lot of stuff that would just disappear. I'd even scrap out some stuff that's good, toss it out and get rid of it. But at the same time, I can't get it out of the basement. It's an old bed frame that I tore apart, took downstairs, put back together, and then put some plywood over the top of it. I can't remember. I think it's 2 sections of 3/4. I laid on it and made a beautiful, hard-working top. It's nice. But what am I going to do with it? It's going to turn into a woodworking bench. And clean out one end a little bit more, and it's going to be a woodworking area. I don't do much woodwork. When I do, I enjoy it. I really do. But once I got into these back when I was 8 years old, 7, 8, just couldn't get out of it. All right, so that's Pops for today, and there's your piston. Now, this one too, I should say, is a fully skirted piston. Now, some of them are Cummins ISX. Literally is a 2-piece. The piston, where the wrist pin is in here, these ears will be attached on legs to the crown up here, and the skirt from here down will be a separate. But it too will still have bosses in there for the wrist pin. There's just enough room for the rod in the middle. Then there will be legs and bosses for the crown, and then there'll be bosses for the skirt, and the skirt and head will float. The idea being the skirt keeping the pin centered where it belongs, and the head able to float and allow for a better seal. The skirt stays cooler, and the skirt can be aluminum, and usually the head is iron or steel. And they're hoping that they get more strength out of it. Cummins was hoping in the early ISX it would be a temperature control as well, because your oil could cool the aluminum better, so there'd be more clearance control down here. Cooler, because oil could circulate all over the place, and still have a better alignment with a piston head. And what happened? The durability went out the window. Because they had a very short connecting rod, which meant that the angle was severe. So it was taking this that no longer had the upper support and didn't have the solid wide bosses in here, and the rod would push. Then it would crack the skirts. That's one. That happened occasionally. Most often what it was a valve keeper had a problem, dropped a valve, and because this was a trunked piston, not a solid piston, it hit that valve and turned that top over, and I saw 3 engines, I think it was, that were total destruction. The only thing left, the only literal thing left, usable, was maybe a couple of connecting rods and a flywheel. The front cover, the valve cover was destroyed on 2 of the 3. It was a complete clean out. The block was disconnected. If it didn't have the crankshaft in it, it wouldn't have been together. It would have fallen. There was nothing there. Tore the head out completely on one of them. Total. One, and the other two came in with only the head holding the engine together with a crankshaft. True story. I saw them. I think I was one of the ones that got involved in pulling the engines out of a couple of them. That's many years ago now. So anyway, that's where we're at, just to give you an idea. And your cars are similar idea between the two. They want it lightweight. Well, it's held here, so you'll see a wide skirt come down to a tab further down here to help control. But on the sides here, almost nothing. And why do they do that? The main reason is they can have very tight tolerances here. And as everything starts to expand, around the pin bosses where the metal sticker, the aluminum, it'll expand sideways. But there's nothing there. And the crown is a much smaller diameter usually, in the neighborhood of 10 thousandths to 20 thousandths, or sometimes more, but usually only 10 or 20. Smaller than the skirt, so there's a little give there as well. But they're connected here, and it's still a solid piston. And what problems do they have? Well, the same thing when you get an engine just like the ISX Cummins, the 2.3 Ford, the rod is barely over 5 inches long. They made a short, compact engine. And the skirt on a piston does not do well if it's not perfectly installed. They're one of those engines where if you do not heat the rod and push the pin in that way and set it, you might have trouble later, because I put several of them together in a press and ended up with one of them cracked. I put 2 sets together and ended up with a cracked and another one, a deformed piston that fortunately didn't crack. I was able to get it back to shape. Don't ask how. So they're a little more, you have to be careful. And at the same time, because of that rod, that would bang that skirt against the wall. And I've heard of multiple engines that got to 125,000 plus miles that broke the skirt out of the piston and had never been apart. So that's one of the failures of that piston. You get the rod too short, too much side thrust, like the ISX or the 2.3, you have a problem. He took the 2.3 and found a way to put a Chevy rod in there, a 5.7 rod. Well, they had to modify it because the 2.3's big end is much bigger than the Chevy 350. So they did a combination rod and put it in. They got with the Ford holes in the Chevy style rod, put it into the 2.3, and they said the engine was entirely, completely different. It took its power band for the small circle tracks in the region here that guys ran like Afton, the street stocks. They said it took their power band an astronomical level, much further down, but even more so their upper end. They said you could feel the torque all the way through to 7,000, 6 and 7,000 without a problem. One guy says I was able to put it in a gear and just let it go. So the length of a rod makes a difference. What's another one? The most well-known engine in history, diesel that is, on the road even, and even industrial, was the old N14 N-Series Cummins. And if you put an ISX next to an N14, there's probably, I'm going to say 4+ inches difference in the block height. No, they're trying to make a more compact engine. With a longer rod, the N14 and the N-Series could turn to 2,500 RPM without a problem. All day long for 500,000 miles. It loved it. The longer rod allowed longer life because the piston didn't have so much force on it. I know, the longer rod means it can flex, but there's a lot of things that go both ways. The ISX is a more rigid engine, but it was limited to 2,100 RPM. You didn't go over that because of the friction, the weight, the force, and everything, etc., etc. Plus your vibration, that's all involved, can start causing more trouble otherwise. The N14, one guy told me, he says you can run that at 2,500 RPM and over rev it a little bit going downhill to 26, 27. But he says, you get to 28, you better be thinking of an overhaul. And when you tag 29, it's all over, junk the engine. Or go through it completely. Because he says, it will not take that RPM. The ISX, I don't even want to think. Some of the industrials they had set up to turn 2,400. but not many. Almost everything was rated at 1900. So that's another one of the ideas of longer rod, not necessarily longer stroke, but a longer rod. Longer stroke just makes it easier to get the power down to the crankshaft. Ford proved that with their 401. They made a 458 out of it, and it was a totally different engine. Same base design, but they redesigned the block to be more rigid, to handle the longer stroke and a little taller. And I ran one of those Genesis engines, was working on it one time. What a powerhouse. It only rated 190 horse. But it'd take a pump that was running 30 gallons a minute, that was on full stroke and full pressure, and right off of idle it'd struggle for a little bit, and then once the turbo got whirling, just as if there wasn't even a hydraulic pump running. Get to the top, you run, even with a hydraulic pump on full. Trust me, I tried to tell that outfit too many times that that pump was bad. So that engine got well tested. All right, that's what I've done for me. 36 minutes in, avoided the hour. You've got a little bit of piston information. Something to go to Steve Morris Engines on spark plugs that was interesting. And in our gassers like I'm running here, diesels has a similarity. But he was going by watching when you fire the engine up and run it under a load, and then he checked the mark on the side electrode. There'd be like a gray line in there. He says if you could get it roughly in the middle between the tip and the outside edge, you've got your timing right. Now, I forgot which it was. One way or the other was too much timing, and the other was too little timing. And then you'll have to go in and check what he has there. For the most part, for me, in the engines I'm working on, I'm not running, thousands of horsepower. Stuff we're running out here with the tractors and such, you pull it up, you take a look at the porcelain, you have an idea just by a quick little rough look at the porcelain. And like he said, yes, that is a great indicator, but that's not the only indicator. It says he runs his timings on the dyno by watching that little mark on that side strap. It tells you what your timing is because of the apparently peak cylinder heat and how hot that little side strap's getting. Just something to keep in mind when we're going through this stuff, because a lot of our antiques are gas engines. In the diesels, what's the similarity? The similarity in the diesel doesn't exist because of two reasons. When you're taking the engine apart, you're looking at the combustion deposits period. Now on an M11, L10s, and the old Cummins, they used to run hot and have carbon akin to a working gas engine, literally. Smooth tan deposits. It really burned harsh, but it was a short stroke engine. So that's one of the reasons that we had that. Let me check my time. Okay, still pretty good on time. And in a diesel, what you're looking for is you can pull your injector tip out and you can see the deposits on the end of it. And there shouldn't be that much on the end of it. If it's a good burn, but you see a lot of fluffy deposits, it's basically burning almost all the fuel, but still it's running rich. You got a little bit too much in it. The exhaust smoke is one of your bigger indicators there. Used to be. No, not so much anymore. But your exhaust smoke, they used to say, with if everything else being equal, if your smoke is black, comes out nice and black, or even thick black, now you're starting to get into advanced timing, depending on how it's burning. If you're under a normal load, you're probably not going to have a lot of smoke out of there, just a haze. But if your timing's too far advanced, then you can get into more black smoke. If it's retarded, it starts to change to more of a blue color. Blue haze versus black haze. And you can tell. One of the problems you have with advancing the timing is it starts to fight itself and overheat the cylinder. And you get pressure spikes when you're going in there. When you retard it, it never fully burns on the way down. So you actually have raw fuel oil coming out, even under a load. So those are things to keep in mind because I've done it before on some machines that had hard starting, and they were throwing blue smoke all the time, where 2, 3, 4 degrees advancement, just try one, then try the other, changed how the machine started as well as how the smoke that came out of it actually cleared it up. So one guy complained because he was trying to fog out a bad manager in the company we worked at. He says, "You took the fog out." And he did. He tried to drive right by his vehicle as he got out, and he mashed it. He knew he wouldn't get fired. I would have gotten fired to do it, but not him. All right, time for me to go. And there you are. You know that I'm not nuts. Catch you later.